I first have to get used to this because I've never used it, so let's try it out. No, that wasn't it. That was it. Okay, so where do we start? When we do practical training in a clean room environment, we have, first of all, to consider the student perspective, because students get in there and they are overwhelmed. First, they have to deal with the tasks they should do, so the experiment itself, where they should learn something that is correlated with the course, and they should produce data correctly, so at which point should they measure and how should they do it. That's the technical part. Then there's the equipment. There's probably a lot of machines they've never seen before that are quite expensive and also quite unusual because you're in a clean room environment, everything is shielded and you can't really see anything. And still they need to know how do these machines operate and how can I interact with them. So if I do want to measure something, how do I get the machine to do what I want? And then there's a third perspective, which is the environment itself. So students are in that clean room environment and they're usually not aware of what that means. So what happens if there is an emergency? What should I do? Should I stay here? Should I go? Where should I call? Or something like that. And also it's like, what do I do in such an environment? You can't run in a clean room, but also you shouldn't walk too swiftly, which is something that you're not aware of when you haven't worked there. So they need a short introduction into that before they go in there. So we need to address all these three parts, but now we switch perspectives to the teacher. What do they want? So the teacher says, well, clean room resources are valuable. We don't want all students in there, we only want prepared students. And we want all the students to take the practical training exactly once, so there's no option of failure. If you can't do the experiment in the first run, sorry, you're not able to do it a second time, because we cannot do that. We don't have the time, we don't have the resources. Which is why you need to be prepared very well as a student, and as a teacher, we need to ensure that that is possible, so that students are not overwhelmed, and students want to learn in that environment. So what do we do? First of all, how do you learn? Well, you usually should use different channels. So don't just talk to someone, don't just give them a PDF, but make it interactive. And then people should remember more of the contents. I don't know whether these numbers are correct, but it's a tendency. You know, when you use more channels and become active yourself, you tend to remember more. So that's what we try to incorporate in our preparation for students. And also, that's not a way you only take once. You do need to repeat your contents. So you can't just tell students, this is how it works, and then expect them to work with that information and do it properly. You need to give them the possibility, and also you have to kind of push them in the direction to repeat contents and to repeat knowledge, just to be on the safe side so they know what they are doing. Oh, there we are. So what kind of resources can we use? What do we use? We have text-based material, obviously, because we have our lectures, we have the slides for the lectures, we have, you know, PDFs and pictures and how do these machines work. Then we use instructional videos, especially about machines that are being used. I will show you one later on. And also we are trying to use interactive lessons. Like, for example, in Moodle you can implement a lesson that gives you feedback on what you did right or wrong, and if you do enter the correct answer, you can go on with the lesson. And if you don't, you need to repeat that part. So we can make absolutely sure that students at least once do all their learnings. Then we have an area to collect questions, because you can't do everything on your own. you need kind of a feedback. But in order for that feedback to be really good, you need to collect questions first, so the lecturer can prepare for this occasion. And then we also use a live stream from the laboratory. So once students are prepared on their own, they're basically being taken into the clean room. We do that on a very low technical level, so we use WebEx conference, for example, and then one member of staff goes around the clean room, shows students, this is the machine, this is how it works. Do you have questions? Should I open something up? Can I do something to make understanding for you easier? And students can then interact with that person because it's a conference tool. Okay, so how do we organize all of that? Well, we use a Moodle course. It's not really important that you read all of that. It's just for an impression, that's what the Moodle course for one laboratory, in that case, screen printing laboratory, looks like. So what do we have here? We have the general information about the low temperature co-fired ceramics technology, and about measurement principles for the machines, and about materials that are used, in this case, printing paste materials. Then we have the next part, where we have specific information about this laboratory. So what is screen printing? What are the parameters that we need to take into account in order to make a good print that we can use later on? And then there are two more things. There's an access test, which I will refer to later on as well, which makes sure for the lecturers that only students who are well prepared come to the laboratory. So we need to have some kind of threshold to make sure only prepared students come. Otherwise, we have kind of like a touristy perspective as well. So students who want to look at the clean room, which is totally understandable, but there are different tours for that. We don't want that in our course. And also, there's a protocol template that students can use in order to give a good and structured protocol, because they need to hand in that protocol. That is the part that is graded afterwards, and that's what they are all working towards during the whole process. So, what about the material? What do we use? For example, as I said, PDFs. That's quite easy and straightforward, but if you remember the first page, that doesn't really help a lot, because students need to repeat that information, they need to be active themselves, which is why we use interactive work in Moodle as well, so do exercises. There's a large pool of exercises. These are two examples that are also referring to that material. They're even using the same pictures, which is helpful sometimes because students kind of remember better. And then they should fill in something. And in the bottom here, you can see that they get feedback, whether it's correct or not. They even get a correct answer if they filled something in and think that's it. And maybe they can go back and repeat whatever was written there or do another exercise. So they get a lot of training if they want to. Then we have an instructional video which should play here. How do I start it? Okay. Not really. Cool, there should be sound. Okay. Not a problem. It's just an example of how the screen printing machine is used by an experienced member of staff in our lab.
First, the squeegee is installed in the squeegee holder. For this, the diamond squeegee is inserted into the holder and installed hand-tight with 3 screws.
Fine.
There are 4 pots.
So this is the preparation of the squeegee, which moves the paste on the screen in order.
Well, it is then installed in the screen printer. Now comes the screen. It has been prepared and is now being installed into the screen mount. Here too, The screws are tightened hand tight. Then the screen is cleaned again with a clean room cloth to remove any fluff.
There's the clean room cloth.
The screen is inserted into the screen printer until it is locked. Next, the software is prepared for printing. The functions upper part, locking, screen clamping, and vacuum are switched on and the basic position is established. The vacuum is now applied to the print nest. The test tape can be placed on the print nest as shown in the video. Print nest and tape are retracted and used to adjust the snap-off distance. The snap-off distance must be set for each printing process. It is essential for the quality of the printed image at the end. This requires a lot of experience and a sure instinct. The screen is brought into the printing position without paste, and now the snap-off distance is first set manually.
At the same time.
The goal is to bring the snap-off distance on the tape to 0. Here in the picture, you can see that there is still space between the screen and tape. Now the screen slowly descends to a snap-off distance of 0. As soon as the screen is on the tape, the snap-off distance required for printing is set and saved.
Okay. I didn't know how to stop that video otherwise, so it was just an impression of this is our machine, this is how it is operated by a professional operator in our lab. You will be able to use that machine to a certain degree, not everything you should do, not everything, but in parts. Students will be involved in mounting the machine, for example, or in using the tapes that are being printed. So they have a first impression of how does this machine work. Then we have the other aspect of you've produced something in the lab, you printed something on a tape, congratulations, what do you do with it? Usually you should measure what you did, because otherwise you can't really evaluate what you have there, because it's small structures, you can't really see it, you use a microscope. And for that we use an instructional video as well, which is in this case interactive. So, can I have, oh yeah, there we go. You see the small dots down here, right? I won't show you the video, but those small dots indicate that there's an interaction within the video. So when the student watches a video, he will, at a certain point, see, aha, this is what's being shown, and also there's an exercise that you need to do in order to give feedback whether you understood it correctly or not. I must say, we as lecturers do not get that feedback. It's only for the students. So it's in their responsibility to be prepared and to come prepared to the lab. Then we have the protocol, which is available to all students beforehand. So it's nothing new they get in the clean room, but they see it beforehand, they see the questions on it, they see the structures that are going to be printed and evaluated later on. And it is meant as a visual guidance, really. So students don't have to keep everything in their heads because they can't bring anything into the clean room, but all material needs to be provided in the clean room. That's an example of what it looks like. So down here you can see that's the structures that are being printed. In here is highlighted, this is what you should measure later on with the LSM, the microscope. And also there's some questions to be considered that need to be answered in the protocol later on. But since you know those questions beforehand, you can gain your knowledge beforehand. So kind of in your preparation, you know what you're looking for. Okay, and then there's the access test, which is, for lecturers, very important, because that's the gateway where students that do not have a clue cannot get into. Those students that pass the access test and are very successful at it, they are allowed to then inscribe into a date for the laboratory itself. And Once they're inscribed into a DAAD, they will form a group with the other students with the same date and time. And from that point on, that's the latest point where they form a group, they can interact as a group as well. So to us, it's not important that every student gives their own protocol. To us, it is important that they work together and maybe discuss their findings and then hand it in as a group. So we want individual preparation for students, which we test hopefully by this. But it is enough for us to get a common protocol, just to see what they did and did they think about everything. Okay, there's some questions that are used in the access test, which is also, I must say, a pool of questions. Students only get 10 questions at a time, but it's a huge pool, so when you do it a second time, you usually don't get the same question twice. So you should know what you're thinking about and not just, remember the answers from last time. There are simple questions like that, definitions, and what are simple Zusammenhänge? Right, connections. And there are more elaborate questions where you should calculate something or, think of one subject from different degrees. So what kind of influence does one typical parameter of the screen printing process have on your outcome? In this case, it's here. Sorry. Where do we go? There we go. Here. So which technological parameters do influence the layer thickness that is being printed? Okay. What else do we have? As I said already, only with a passed test, students get a certificate and then they can enroll into their groups. We have this live stream, which I didn't show you because it's quite hard to show. But I can assure you, WebEx conferences, and it's exactly the same, just that you have a mobile camera and can walk around and let students look at whatever they like or whatever you like them to see. If students do come prepared, we know they have put a lot of effort into that preparation, usually, or they are just very smart and know everything from scratch. But we don't really emphasize that the protocol needs to be high-end. They just need to repeat what they've learned so far, and we want them to also have fun with the laboratory. So once they've done the hard part of the preparation, we want them to be engaged and actually have fun working in the laboratory, because that's usually a part where students kind of shy away because they don't want to handle the machines. They know they're expensive and, materials, they're hard to get. And we don't want that. We want students to be confident that they can do it, and that's what we convey in the protocol. So to say, if you do something, it doesn't matter what the outcome was, just tell us why did it go wrong. That's basically our intention. Right, that's all from me. And I have 2 questions, but first, thank you for your attention.